Hello everyone and welcome to today's series of webinars. What's new in the BIM connectivity between Revit 2024 and Advanced Design 2024? My name is Evelina Palkanoglu. I'm a structural civil engineer with a PhD in computational mechanics, and I'm also a solution specialist in GRAITEC for advanced design. Today we will see how we can use the workflow between Revit and advanced design, and we can also see all the new features that they can accelerate the process and make the workflow more effective and efficient. First of all, I would like to define what is BIM. BIM stands for Structural Building Information Modeling. It's the process of creating a digital model of a building structure components using specialized BIM software. The primary goal of structural BIM is to create a comprehensive three-dimensional representation of a building structure to facilitate communication, coordination, and collaboration between the various stakeholders involved in the design, construction, and maintenance of a building. Now it's about time to see how the BIM workflow works between Revit 2024 and Advanced Design 2024. And what are these new features that they can accelerate the workflow. In this slide, we can summarize the workflow between Revit and Advanced Design. So the workflow works as following. The model can be transferred from Revit to Advanced Design, following some modifications that need to be done in Revit. And then after analyzing the model and perform any design, any modification on the sections based on the design, the model can be transferred again from Advanced Design back to Revit and be able to access the results we obtained using the finite element analysis of Advanced Design. This is the basic concept. This is a summary of what I'm going to show you today. And this is basically the whole concept of the synchronization between Revit and Advanced Design. First of all, I would like to spend a few minutes and introduce the concept of the analytical model. And the analytical model is a concept that exists in Revit and can be accessed through the Power Pack, as we will see later on during this session. The analytical model is independent of any physical model, exists in Revit. The analytical elements can be created without the need of other objects. You can link the analytical elements to their physical counterparts. Analytical elements are not deleted if these counterparts are missing. And the analytical elements react on physical model changes only on demand. Here is a physical and an analytical model, so we can see that the difference between those two. On the left-hand side is the physical one, and on the right-hand side is the analytical one. Just a quick comment, the analytical one is the one that is needed in order to introduce this model to Advanced Design and perform any analysis and design, is the model that the finite elements analysis can identify and analyze, whereas the physical one is the one we create in Revit, and most of the time needs to be transform to an analytical one in order to introduce to advanced design and perform these workflows we introduced earlier. This slide is about the generation of an analytical model in Revit. So the creation of structural analytical model is accelerated using the Power Pack for Revit 2024. Having installed the Power Pack for Revit 2024 and using the ribbon that comes when installing this plugin, you have the option to create the analytical model by selecting the physical model on your screen or automate the analytical model generation. The analytical elements can be created without the need of other objects, and the analytical elements can be linked to their physical counterparts. Another way of creating analytical members is from scratch. So you can create analytical members such as analytical columns, beams, bracing elements in Revit by creating the analytical member without any physical member before. So selecting all those options that exist in Revit, you can create an analytical member using the start end point definition or the top point definition. And then you can use the different geometrical features such as the line, the arc, or the circle to draw this element. 2D elements can also be analytical and can be generated in Revit 2. So we have the concept of an analytical panel. The analytical panels are used to represent the structural walls, the floors, any panels. And you can create an analytical panel. You can also edit the boundaries, so you can adjust the nodes and the edges of the panel and create any geometry that you wish. And by creating an analytical panel, there is still the option of having an analytical opening, which means that this opening, when you are going to transfer this model to advanced design, it will be identified by advanced design, and the finite elements analysis will be performed considering this opening. So using the option and the opening tool by phase, you can create an opening on the on any analytical panel you create in Revit. Here in this slide, we can see the difference between an analytical and a physical model when it comes to the properties. Window that pops up whenever we select any element in Revit. So on the left hand side, we have the analytical one, and on the right hand side, the physical one. On the analytical one, we can see the structural role of the element as well as its material. On the physical one, we normally see any information related to the levels, or in which floor, such as here, this is a column, and we get information about the levels, the floor that this column belongs to. So this is pretty much the difference between an analytical and physical model when it comes to the properties the user sees on their screen on Revit. There is also another tool that is used to facilitate the workflow between Revit and advanced design. This is the analytical automation. Can be identified by this icon. the analytical automation can be summarized by the following statement: is the independence of the analytical model and the physical model. All the information related to newly created physical elements are automatically assigned to the analytical elements. There is no need to redefine the material or the structure role of any analytical element. All the information have been transferred when you link the physical with the analytical elements, and any changes made to the physical model will be automatically assigned to the analytical model. So not only the information when you create the model has been transferred, but also any changes, any alterations on the physical model will be automatically assigned to the analytical model. There is also the idea of fixing any errors on an analytical model. You can use the icon detect errors to detect any errors that exist in the model. And you can use the trim or extend functionality of Revit, so you can close any gaps that they have been created when creating the physical model, or trim any beams or any columns that they extend outside of the level that they have been created for. Those functionalities are very interesting because say the whole concept is very beneficial for the user because it saves so much time when the model is transferred to advanced design. A quick comment here, there is also this option to fix the errors in advanced design, but I think it would make more sense to import a clear corrected model in advanced design before performing any finite element analysis and design. But still, advanced design, in case you haven't performed any fixing errors procedure in the Revit, advanced design can identify any errors existing in the model, and you have the option to perform the same process to fix the errors, but in the interface of advanced design. Also, there is the option to adjust the analytical members. Either the position of any analytical members can be controlled. You can adjust the member when selecting the analytical member, and you can toggle between the global coordinate system and the local coordinate system when it comes to analytical members. After establishing any settings, the user is ready to export the file from Revit in order to import it to advanced design. There are two different ways of working, either selecting automatically the export of file directly to advanced design by selecting the advanced design icon on the ribbon on the Revit interface, or by selecting the export functionality on the BIM Connect window, the one that is marked with a red rectangular on this slide, which pretty much creates a file that the user is going to import in advanced design later on. So you select what type of file format you need to create, either a GRAITEC, BIM, or other formats. In order to import it to advanced design, a GRAITEC BIM file format is mandatory to be created, and then the model is imported to advanced design. So the user needs to open the advanced design, and from the BIM functionalities on the interface of advanced design to import the model they just created, they just exported from Revit. either selecting the automatic export of the file into advanced design or um, um, performing the export import process. The results are exactly the same, and both procedures end up in creating a workflow from Revit to advanced design. When the import is done, there are a few things that needs to be established in advanced design. First of all is any project settings, such as name, address, project number, or any unrecognized sections or materials are necessary to assign, first created in advanced design and then assigned. So the user needs to do some modifications before performing any analysis and design in advanced design. Some key points between the operability in advanced design. You can see, access and manipulate items in the advanced design browser panel, and you can see and adjust properties in the properties panel. So if the model has been created correctly in Revit, on the left hand side you can easily access the model tree and see the different levels, and on the right hand side, by selecting any member or any group of members, you can access the properties of this group of members or an individual member. Also, as I mentioned earlier, there is the check control with pretty much the same functionalities as we saw in Revit earlier, where you can check for any errors in the model. The errors are identified by the software and they are marked with a red circle. And the user has the option to use the auto trim or auto extend, stretch to node, offset, projection on a plane to fix all those errors in order the software can perform the analysis and design. After fixing any errors and the model is verified and evaluated, the analysis and design can be performed, finite element calculation can be run, and any errors will be displayed at the bottom of advanced design interface, so the user knows any corrections that they need to make. Otherwise, if there is no error and they are just warnings, it's up to the user to decide if they will proceed with the results or they will go back to the model, fix any warnings. So basically, they can launch the results and see any results or perform any post-processing of the results. So now, after the analysis has run and any requested design has been performed, the user normally wants to transfer the model from advanced design back to Revit and access all these informations related to the results from the Revit interface. So again, this can be done really effectively and easily from the advanced design interface. First of all, some settings need to be established first, and then the user needs to follow the exact same procedure as we saw earlier, with the only difference that now the process is the reverse one. So first of all, they need to establish some options related to the linear elements. The settings are related to the forces, where the forces are going to be exported on the linear elements, and what type of results the user wants to be transferred back to Revit. Then, following the same procedure, an GTCX file, a GRAITEC format, needs to be exported from Advanced Design in order to import it back to Revit. In order to import the file back to Revit, the import functionality is selected from the BIM Connect options from the Revit interface. And the model is now imported from Advanced Design back to Revit. A few tips. The user is advised to open a new Revit project in order to import all the results from the Advanced Design to avoid any overlaps. And also is recommended to use the import function rather than the synchronize function in order to perform the workflow from Advanced Design to Revit. Again, the operability in Revit when importing a file from Advanced Design. The analytical model that is created in Advanced Design can now integrate it in Revit. A quick comment here is this can work also separately. So a user, for example, can create a model in Advanced Design, and when finishing the model, performing any analysis, any design, and obtain the results, they can transfer the model back to Revit. So, for example, instead of having a model in Revit, transfer it to Advanced Design and back in Revit, you can have half of this workflow by creating the model directly in Advanced Design and perform the synchronization. And also, using the function Results Manager, which can be found with the colorful icon on the structural analysis functionalities in Revit, there is the option to display the results of the 3D analytical model that has been imported from Advanced Design. And the results that the user is able to access is the ones that the user selected to import from Advanced Design to Revit. So the workflow can be summarized in the following slide. So we have the physical model in Revit. This model is transferred in Advanced Design by creating first its analytical model. This model is analyzed and designed in Advanced Design. Any modifications on the sections might happen as well. And all this information are transferred back to Revit, as well as any results and any design. A few quick comments about the workflow between Revit and Advanced Design. Focusing on the first part, from Revit to Advanced Design, the BIM Connect performs the export prioritizing the parameters of the physical model. So, for example, if the section of the physical model is different from the section of the analytical, the member in Advanced Design is expected to have the section of the physical model. The models in Advanced Design are exported in their respective positions. The physical model is used as representation. The analytical is the one that is used for calculations. A few clarifications about the concept of the physical and the analytical model, which is their role, after all, in Revit and Advanced Design. On the workflow from Advanced Design to Revit, It's important to set up the export options. So to select what type of results you would expect to see in advanced design when you perform the export, and also where the user wants the export forces to be exported, and also to export the result as a GTCX file, the GRAITEC format. This is the file that needs to be imported in Revit in order to be able to access all those information from advanced design. There is also the option of synchronization. The functionality of synchronization gives the user the opportunity to see all the elements that they are new, modified, deleted, or any data that hasn't changed. So, for example, if any design has been performed and any sections failed and they have been substituted, if the user substitute those sections with other sections in order to pass all the checks, the user is able to access those information when import a file from advanced design to Revit, and there is a legend also to see which one is new, which one is modified, deleted, unchanged, and all those information. And also there's the option to see the reinforcement if concrete design has been performed for the concrete elements of the structure. Also, the finite element results can be accessed on Revit interface, and those results come from the analysis performed in advanced design. The load combinations can also be accessed in Revit, and all the numerical results related to those load cases and combinations can also be identified and accessed in Revit when the transfer from advanced design to Revit has been performed effectively. This can be performed using the PowerPack function import analysis results. Again, I would like to close this session by summarizing again the workflow between Revit and advanced design, and I think the summary of the whole session is this slide, where using the BIM Connect, which is a basic concept on both softwares, in Revit and in advanced design, having exactly the same functionalities, import, export, synchronization, the user has the opportunity to import and export files from one software to the other, perform different processes, and without losing any data and any information, can import those files back to the other software without spending time, and also without losing any data. A few conclusions before closing this session. The analytical model is now a standalone concept. The analytical model is independent. Generally, the concept of the analytical model is predominant in the workflow between Revit and advanced design, and is basically a very powerful tool in order to perform this synchronization between the two softwares, and the link of Revit models to advanced design and advanced design models back to Revit. So as I mentioned earlier, the BIM Connect, this tool that exists in both software, is a very powerful and efficient tool in order to exchange data between the two softwares efficiently, effectively, easily, and without any time consumption.